Welcome everybody. This is the Minerals Study Guide video for this unit talking about the properties of minerals and how to test for different minerals and identify minerals. So we'll start off. I'm going to go through these slides. You can feel free to rewind at any time or fast forward if you understand certain slides. But I'm going to go through pretty quick. So let's get started. There are 5 properties of all minerals that they all have in common. The first one is that they're naturally occurring. So what that means is that they're created in nature, found in nature. It's not made in a lab or synthetically. So these are all naturally occurring. Next two, the first one is inorganic. When you look at this prefix here, in means not, like invisible or incorrect. In means not, and organic, if you think of another word, is organism. So not an organism, meaning it was not a living thing or it was never a living thing. Number 3 is that it's solid at room temperature. If you look at all the mineral samples, we don't have any minerals that are in a liquid or a gas state. Number 4 is the crystal structure. So in minerals, the molecules line up in a very specific pattern. And depending on that pattern, that gives the mineral some distinct properties like hardness and crystal shape. But every mineral has a crystal structure where the particles are lined up in. Number 5, the last one is definite chemical composition. So what this means is that minerals are always made of the same elements and the same amount of each element. So another thing that I like to say is that minerals are pure substances. And then the mixture, if you have a mixture of minerals, that's called a rock. And so a lot of times minerals will be in rocks that need to be separated. If people mine them, they want to separate the mineral out of the rock because the mineral is the pure substance. The rock is a mixture of those. So now, if you have a mineral, you can ask 5 questions here that you should be able to check off each one of these boxes, and if it meets all of those 5, then you have yourself a mineral. Naturally occurring, inorganic, solid, has a crystal structure, and a definite chemical composition. Check, 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 check. Identification of minerals. The first one, easiest one to see, but least helpful, is color. The problem with color is that sometimes the same mineral can have multiple colors. For example, quartz can come in over a dozen different colors. Fluorite can come in green and purple. And so if you just look at the color, it's not going to be conclusive. Almost the same with fool's gold. If you look at just the color, you'll say it's gold, but you have to do some more tests to figure out what it actually is. Alright, is called streak. And streak is the color of the inside powder. What you do is you take your mineral and so this is my mineral here, and you're going to scratch it on a streak plate and it'll leave a mark, which is actually the powder that's rubbed off of the mineral, and the color of that powder is called the streak. What's kind of interesting is that not all minerals have the same color outside as they do the powder on the inside. So for example, fool's gold has a gold color, but then when you scratch it on the plate, the streak is black. So that's a interesting characteristic of some minerals. Next is the luster. Luster is how light reflects off a mineral. So for 8th grade, we say, is it metallic or non-metallic? There's many kinds of non-metallic lusters out there, like glassy, pearly, waxy, dull, vitreous. These are all non-metallic lusters. For 8th grade, we're talking metallic or non-metallic. And the best way I can describe that is, does it look like a metal? You probably have seen a lot of metals during your life. You know kind of what a metal looks like. sometimes they're shiny, sometimes they're not as shiny like a cast iron skillet, but you can still tell that it's metal. So those would be metallic. Non-metallic would be everything else. Hardness, this is one of the best ones to use, the best ways to identify a mineral. And you take your mineral and you start scratching it on a bunch of other substances, and you narrow down its hardness based on that. And the scale that we use for that is called Mohs hardness scale. All right. And Mohs hardness scale simply has a bunch of materials and minerals that it gives, starting at the softest with talc. This is easily crumbled even in your fingertips. It's very, very soft. Moving up the scale, we get harder and harder until we get to diamond, which is the hardest natural substance on Earth. The only thing that can scratch a diamond is another diamond. So the main idea here is that if a mineral like topaz is rubbed against quartz or anything below it, topaz will scratch quartz because it has a higher hardness. And so using that idea, you take your unknown mineral, here's my unknown mineral right here, and you're going to start by scratching it on known substances. You'll start with your fingernail. If the mineral can scratch your fingernail, then you move up to the next one, and you know it's above 2.5. If your mineral can scratch a penny, you know it's at least 3.5, so you move up to a nail. Now let's say that it can scratch a nail, but it can't scratch glass. Well, I know that it's above 4.5, and I know it's below 5.5, so it's probably a hardness of 5. And you can do that for any unknown mineral. Now, it doesn't necessarily that it means it's apatite, but it's a mineral that has roughly a hardness of 5. Okay. Density, this one is an old one. We've talked about density the whole school year. Remember, density breaks my heart. There's my arrow. Mass divided by volume. And so you're going to measure mass, which is in grams, and volume, which is in milliliters or centimeters cubed. Those are 2 units for volume. And you'll divide the grams over the volume, and you get density, which is in grams per milliliter. That's the 1 unit, or grams per centimeter cubed. Those are the 2 units for density. Okay. Next, crystal structure. This is going back to what we talked about, how the molecules are lined up and the elements are lined up in the mineral itself. You'll see some minerals have crystals, like for example quartz has a very nice hexagonal prism that you can see when it's in crystal form. And other ones you can see different geometrical shapes, so that could be a way that you can identify it. Cleavage and fracture. This is how a mineral breaks. So if I were to take a mineral and a hammer and smash it, what are the little pieces going to look like? Okay? For cleavage, to cleave means to split in half. So if I like to think about a cleaver, which is like a big butcher knife, chopping down on a piece of meat, it's going to cut that right in half, and there's going to be smooth surfaces. So these minerals that have cleavage break on smooth surfaces. It might be little flat sheets, it might be all sorts of three-dimensional shapes, and that has to do with the molecules and how they're bonded together, because it's always going to break on the lines of least resistance. So in this case, for feldspar, if I were to take a feldspar and break it into pieces, it's going to look, each small piece is going to look similar to the larger piece. Of cleavage is fracture, or fracture, it's just going to break on irregular edges, or sometimes it'll be called conchoidal fracture, where there's little curves. You'll see these little curved lines like that. That's also fracture. So if it's If it doesn't break on those flat surfaces, it's called fraction. I want you to think about if you have a bone, here's your hand, and you break your bone in your arm, it's not going to be a smooth cut, it's going to be jagged like a fracture, which is irregular jagged surface. And then the last part to identifying minerals is sometimes you can do special tests, like putting a magnet up or putting iron filings up to your mineral. There is a mineral called magnetite that actually is magnetic. There are some, like calcite, that react strongly with acid if you put acid on there. Some of them glow in UV light, like fluorite. And some of them make a double image, which means you can look through it and you'll see double when you look through it. There are more special properties than this, and not every mineral has a special property, but this is something that can separate minerals out if you get down to the end and you can't figure out which one is which. All right, well, this ends the study session. I hope this helped. If you have any questions, please let me know. You can email me, talk to me in class. What I'd like you to do is come see me. I have retake forms, and we will retake either during lunch or after school. And that will raise up your grade big time. All right. Thank you. Have a good day. Bye.